Okay, let's move on. Let's talk about solving systems of nonlinear equations. Now you know how to solve systems of equations already. You use mainly the substitution or the elimination method. And sometimes one method is better than another. So let's look at the first problem. We have substitution or elimination as our two methods of solving. Now, if we want to use elimination, that means we have to eliminate the same variable. If we want to use substitution, that means we take something and we plug it into another equation, right? So let's look at what we have here. Do you notice the first equation says y equals? I don't know about you, but to me that triggers, oh, this is already set up for a substitution problem. So I think I'm going to solve this by substitution because they already set it up that way for me. Are you with me? Okay, so in the second equation, I have 8x minus, and then I'm supposed to write the y. Agreed? Well, in this particular case, the first equation says y equals x squared minus 2. So out goes this y, and in parentheses always, goes the x squared minus 2. And then that is supposed to equal 17. Cool? Okay, now I have one equation all in the same variable. So let's kind of simplify this and see where we are, see what it's going to give us. I see 8x minus x squared plus 2 equaling 17. Do you notice that x squared? Yeah, that tells me you're going to have to do what to solve that? Yeah, you're going to have to factor it to solve. Now, I don't know about you, but when I've got an x squared, I want it positive because that's going to be, for me, easier to solve. It's one less negative sign to deal with. So me personally, I'm going to take everything from the left and move it to the right, which means I subtract the 8x, I add the x squared, and I minus the 2. So I added the x squared, I subtracted the 8x, and I minus the 2. Well, what's 17 minus 2? Good, a positive 15. Cool? Okay, and now I've got this equation. And now that looks very easy for me to solve. That looks very simple to factor, doesn't it? All right, so you factor it, and let's see if we get the same thing. Did you get that? Cool, which means you have two answers for x, don't you? You have x equaling a 5 and x equaling 3. Yes? Awesome. Now, am I done? Nope, because you didn't just have an x in these equations, you also had a y. So I guess we should solve for y also, because it's a system of equations. I don't solve for just one variable. In this case, I solve for 2. So it's your choice which equation you want to plug it into. Me personally, I'm thinking about plugging into the first one. Why? Because the variable I'm looking for, y, is already by itself in the first equation. So that's why I figure I'm going to use this first equation. So when I plug in the 5 for the x, I'm going to have y equals 5 to the power of 2 minus 2, right? Which is going to give me a 23, isn't it? So we've got the point 5 comma 23. Good? In the second one, I am going to plug in that 3 for x, and I end up with, good, 7, which means I have the point 3 comma 7. Yes? Loving it. Okay, let me back you up, and let's see if these two answers make sense. You know, this first equation, do you know what it's the graph of? Yeah, if you graphed it, I see this x squared, and we just spoke about these x squareds, these graphs of these things with squares in a previous lecture. This is a parabola, isn't it? As a matter of fact, it's a parabola that opens which way? Good. It's a y here, which means up or down, and because that's positive, it means it opens up. So I have a parabola opening up. That second equation, what's it the graph of? Yep, a line. Which means these 2 points are telling you that if you literally graph this parabola going up and you literally graph this line, you would have this line intersecting the parabola at the point 3, 7 and at the point 5, 23. That's what it's telling you. Cool? Okay, hang in there. Got some more examples for us. Okay, so let's look at this second problem. So we have 2 methods that we prefer to use, either substitution or elimination. Which one might be the better one for us here? Good, I say substitution also. Here's why. I don't see any x squareds or y squareds in this second equation that I could cancel it with. Okay, so substitution would be the better way to go. However, they were not as nice to us as they were in the first problem. First problem was already set up. This one we're going to have to work on. So we're going to have to take the second equation and we're going to have to rearrange it for either x or y. And I really don't care which one. Which one do you guys want to use? X? Okay, so let's solve for x. So in this second equation, I am going to move that 15y to the other side. And I am going to divide by that 8, which means, oh, I get this lovely negative 15, 8 times y. And then I'm going to take it and I'm going to substitute it into the first one, aren't I? And you're like, I'm not liking this problem. I get it, but hang in there. It might not be as bad as we think, so hang in there. So now, in my first equation, first thing it says is x squared. So instead of the x, I'm going to put the negative 15 over 8y and then square it. And then plus the y squared equals 289, right? Okay, so we have to square this thing, don't we? All right, what is 15 squared? Good, 225. What is 8 squared? Good, 64. So I have a positive 225 over 64 y squared plus y squared equals 289. Agreed? Okay. Hey, gratefully I have both y squareds here. What's the number in front of this second y squared? Yeah, that's a 1. So I'm going to have to add these, aren't I? Okay, so let's see if you follow along. So I have 225 over 64. Whoops, that was supposed to be 64. Okay, 64 y squared plus, yeah, I'm going to need a common denominator. So how about 64 over 64 y squared equaling 289? Okay, add them. I got 289 over 64 y squared equals 289. Woo! What do you think? Know what you got to do next? Good. You're going to have to get rid of that fraction, aren't you? Which means, yep, let's multiply both sides by its reciprocal. So that drops. Multiply both sides by the reciprocal. Oh my gosh, this problem is a lot nicer than we thought. So it looks like we have y squared equals 64, which is really nice. And then to solve this, you have to, yes, you have to take the square root of both sides. And how many answers are you going to get? Yes, you will get 2 answers. You have one answer, y equals a negative 8, and the other answer, y equals a positive 8. Cool? Okay, are you done? Nope, because you need to find your value for x, don't you? And I don't know about you, but here's where we solve for x. So I want to use this equation because it's already set up to find the value of x. I don't need to do anything. All right, let's look. So this first one, x equals a negative 15/8 times a negative 8. Good, x equaling a positive 15, doesn't it? which means one of my points is 15, comma, negative 8. Let's look at the other one. X equals negative 15 over 8 times a positive 8. So x equals a negative 15, doesn't it? Which means my other answer is negative 15, comma, positive 8. Yes? Loving it. Okay. Now, let's see if it jives. This first equation, do you remember what that is? Yeah, that one's a circle. What's this one? Yeah, that one's a line. These two answers tell me that my line will intersect the circle in these 2 points. Cool? Okay, hang in there. Got another example. Okay, so let's look at this third problem. Again, they're asking us to solve. And so we have substitution and elimination. Which method do you think would be better for us here? Yeah, I'd say elimination. Here's why. Both equations have x squareds and both equations have y squareds. So I'm going with elimination, which means I need the numbers in front of the variable that I'm trying to get rid of. I need those numbers to be the same number but opposite signs. So, what do you want to do? Get rid of the x squared or the y squared? I'm going for the y squared also. Here's why. This y squared has a negative in front of it. This one has a positive in front of it. They're already opposite signs. I just need the numbers in front to be the same. So, what are we going to do? Good. I need this number in front to be a 4, which means I need to multiply the entire equation by a 4. So let's look and see what happens. So my first equation is 4x squared plus 4y squared equals 36. Correct? Are we changing the second equation? No. So I have 16x squared minus 4y squared equals 64. And then I get to add them. Here's a little trivia question for you. The elimination method, it also used to be called the addition method. Why? Because when you added these equations, hence the addition method, one of the variables was supposed to drop out. This variable is going to drop out when you add them. So that's why it was also called the addition method. So it looks like I have 20x squared equaling 100. Okay, so keep up with me on your algebra. Divide both sides, right? That's 5, isn't it? So, oh lovely. It looks, and I got to take the square root, don't I? Oh, lovely. It looks like I have 2 answers. One is a negative square root of 5 and the other one is a positive square root of 5. Okay, just lovely. Well, so be it. If that's the way it is, that's the way it is. So, I found my x's. Now I got to find the y's, don't I? And how are we going to do that? Yep, going to plug it back in. Which equation do you want to plug them back into? Yeah, if I have to plug them into one of these, I'm going for the first one. Why? Because the first one looks like the simpler of the 2 equations to work with. The numbers are smaller. There's no, well, there are coefficients in front of the x squared and y squared, but they're just 1, so I don't have to worry about anything. So, let's check it out. So I'm going to have x being squared. So this negative square root of 5 is now squared, plus the y squared equaling 9. Agreed? All right. When you square a negative, well, that'll be positive. You square a square root, that cancels, right? So I'm just going to get a 5 here, aren't I? Okay, well, that wasn't so bad. Plus y squared equals 9. Need that y squared by itself. Minus the 5 gives you 4, right? And then you got to take, yeah, that's right, another square root to get the y by itself, which means how many answers? Yes, 2 answers. You're going to get a negative 2 and you're going to get a positive 2. So that's quite interesting because what you're telling me for this 1x, I have 2 answers. I have a negative square root of 5, comma negative 2, and I have a negative square root of 5, comma, positive 2. For that one x, I have 2 y's. I got 2 points out of here. Okay, the second one. So we're going to plug in the positive square root of 5, aren't we? Right? And square it. Add y squared equaling 9. So help me out. What's the square root of 5 squared? Yeah, that's just 5, isn't it? Well, this is interesting. Do you notice it's the exact same thing? So do you think if when I solve this side, it's going to be any different than what I got over here? No, why should it be? I'm going to follow the exact same steps. So I'm going to get the exact same y values. But these y values I got from this x. So be careful. That's a different x value, which means I have a positive square root of 5, comma, negative 2, and I have a positive square root of 5, comma, positive 2. This is interesting. I have 4 answers. I have 4 points that are solutions for this system of equations. You're like, how can this be? All right, let's talk a second. This first one, x squared plus y squared equals 9. That's a circle, right? We've dealt with circles enough. This second one, I know you haven't quite seen it yet. You will later, okay? When you maybe get into precalculus. This is known as a hyperbola. And you're like, what does that look like? Consider it a pair of parabolas. Let me get a little board space. I'm just going to do a quick sketch so you can see it. Okay? Hyperbola is a pair of parabolas. And these parabolas either go up, or these up and down, or these parabolas go left and right. And so here's what I know. Since this x squared is first, I know, and it's positive, I know this hyperbola is left and right. And then I've got this circle. Well, according to these answers, my circle intersects this hyperbola in 4 points. 1, 2, 3, 4, which is why I got 4 answers. Just to give you a little quick sketch visually. Does this make sense? Okay, I got one more for us, so hang in there. Okay, so let's look at this last example. Still solving. What do you want? Substitution or elimination? What do you think might be better? Yeah, I'd say elimination also. And here's the deal. I'm noticing the y's are not so easy to eliminate, but what I am noticing is that these x's are. So I am going to take the first equation and I am going to multiply it by a -1 so that I have a negative in front of that first x squared. So I'll have a negative x squared minus y squared equaling a -1. The second equation will remain the same because I'm not multiplying it by anything. Okay? And when I add them, what's going to happen? Good, those x squareds are going to drop out, aren't they? Now notice, I'm going to have a negative y squared, right? Plus this parenthesis squared equaling, yeah, -1 and a 9 is an 8, isn't it? Okay, well, at least this equation has nothing but y's in it, but it's not a very pretty looking equation, is it? Okay, so I'm going to have to clean it up a little bit. So you know what you got to do with this y plus 2 in parentheses squared? Yeah, you're going to have to write it out twice, aren't you? And square it. So let's do that first. Okay, so we got a little bit of side work. And our side work is saying y plus 2 times itself. That's going to help us figure this guy out. Cool? Okay, so I'm not going to insult your distribution skills. I'm assuming that you are following along with what I'm getting. Yes, and in math we assume a lot, but that's how we get things done sometimes, right? Okay, so I know you agree with what I've written there, which means this line now looks like -y squared plus, and what did we just get for that parenthesis square? We got y squared plus 4y plus 4, and that equals 8. Ooh, that's not so bad. Notice what happens with the y squareds. Hoo-hoo, they drop out. Bye. See ya. If they want to go, let them go. I don't want to keep them if they don't want to stay. Oh, now I have a nice little equation to solve, don't I? Okay, so when we just follow through with our algebra, I got one answer for y. I just have y equals 1. Fine with me. Now, we need to plug that in and find our x value. Which one do you want to plug it in for, the first one or the second one? Yeah, it doesn't make a difference, but I agree with you. Let's plug it into the first one because it looks easier to plug it into, doesn't it? All right, so we have x squared plus 1 squared equaling 1. X squared plus 1 equals 1. Oh, even this answer is looking nice. You're like, you're supposed to get two answers. Well, a positive 0 and a negative 0 is still 0, isn't it? So it looks like I only have one answer in this case. I have the point 0, 1. Nice. With me? Okay, so you're like, how can this be? Well, if you notice, the first one's a circle and the second one's also a circle. So here's what this tells me. It tells me these two circles are touching at this one point. They're not intersecting each other. I've got one circle and then the other circle is maybe intersecting at one point, either here, here, wherever. Cool? Okay, so substitution and elimination, those methods haven't gone away. They will help us solve system of equations that are not linear. You have fun with this stuff, and I'll catch you on the flip side.